For centuries, the way we build our homes has remained remarkably unchanged. It's a story of human hands and raw materials, a testament to our enduring need for shelter. We see it in the skeletons of timber frames rising against the sky, in the patient laying of brick upon brick. This method has served us, creating the towns and cities we know today. But this ancient rhythm of construction, so familiar and ingrained in our cultures, is beginning to show its age. It carries with it a heavy burden, one that our modern world is struggling to bear. The process is slow, laborious, and profoundly expensive. Beyond the economic strain, there is a deeper, more troubling cost: the toll on our planet. Traditional construction is one of the world's largest consumers of raw materials. The construction sites themselves generate mountains of debris. Offcuts of wood, broken bricks and plastics, much of which ends up in landfills. Out of this pressing need, a truly remarkable innovation has emerged. It's a technology that seems to belong to the realm of science fiction, yet it is very real and is already reshaping our world. This is the world of three-dimensional printed housing. The concept is both simple and profound. Instead of assembling a house piece by piece, a machine builds it from the ground up, layer by delicate layer. The first whispers of this revolution were heard in China, where in 2014 a company named Winsun demonstrated the seemingly impossible. They constructed 10 small houses in a single day. Using a colossal three-dimensional printer, they extruded a mixture of cement and recycled construction waste, creating the walls of these homes. From those pioneering days, the technology has blossomed, particularly in the United States with the work of a company called Icon. Icon's Vulcan printer, a robotic marvel, can now construct the wall system of a house in a matter of days, not months. They have built entire communities of printed homes in Texas, and have partnered with organizations to provide housing for the homeless. They are not just printing houses, they are printing hope. To witness a house being three-dimensionally printed is to watch a kind of mechanical ballet. It's a process of mesmerizing precision and grace. It all begins with a digital blueprint, a three-dimensional model of the home designed on a computer. Once the foundation is prepared, often a simple concrete slab, the printer is set up. This is typically a large gantry system, like a bridge crane, that spans the entire footprint of the house. The printing begins. With a quiet hum, the robotic arm whirs to life. The nozzle begins its journey, moving with unerring accuracy as it extrudes a thick, continuous bead of a proprietary concrete-like mixture. It moves like a careful artist, laying down the first layer of the home's exterior and interior walls simultaneously. This is the magic of the process. The walls rise as one solid piece. Drone footage provides the most breathtaking perspective. From high above, we can watch the entire floor plan take shape on the ground, like a drawing being filled in. What takes a team of builders weeks to frame is accomplished by a single machine in just a few days. The site is remarkably clean and quiet, with only a small crew overseeing the automated process. The path from a simple concept to a finished, livable home is paved with immense engineering challenges. One of the first major hurdles was the material itself. Early concrete mixtures could be brittle or shrink as they cured. Engineers have worked tirelessly, like alchemists of the modern age, to perfect these formulas. They have developed what are known as mortars, complex blends with precise additives. Another significant challenge lies in reinforcing these printed walls. Traditional concrete walls are strengthened with a web of steel reinforcing bars or rebar, but how does one insert a steel cage into a wall that is being printed solid layer by layer? A far more elegant solution, now being implemented, involves automatically feeding steel wire or cable directly into the concrete mix as it is extruded from the nozzle. The scale of the machinery itself presents a formidable engineering problem. To print a family-sized home, the gantry system must be enormous, yet also capable of millimeter-perfect precision. Furthermore, builders must work closely with local authorities to prove that these new structures are safe and durable. Through rigorous testing, they are steadily building a body of evidence. The most compelling arguments for three-dimensional printed housing rest on a powerful trinity of benefits: speed, cost reduction, and sustainability. The increase in speed is perhaps the most dramatic. A three-dimensional printer can extrude the entire wall system for a similar-sized house in as little as 24 to 48 hours of print time. This newfound speed translates directly into significant cost savings. Labor is one of the largest expenses in home building, often accounting for nearly half the total cost. A three-dimensional printing process requires only a small crew of 3 or 4 people, a drastic reduction from the dozen or more skilled tradespeople needed for conventional framing. The environmental benefits offer perhaps the most profound promise for our planet's future. Innovators in the three-dimensional printing space are tackling this directly by developing new, sustainable materials. Some are even developing green concrete that can absorb carbon dioxide from the atmosphere. This commitment to sustainability means that three-dimensional printing is not just changing how we build, but also what we build with. As this technology matures, our ambitions for it grow ever bolder. We are beginning to look beyond the construction of single homes and envisioning entire neighborhoods created by fleets of autonomous robots. These neighborhoods would not be monotonous rows of identical boxes. The digital flexibility of three-dimensional printing allows for infinite variation. This technology also inspires us to look beyond our own world. The prospect of human exploration and settlement on the Moon or Mars presents the ultimate construction challenge. NASA and other space agencies are actively funding research into this area. These machines would use the local Martian soil, or regolith, as their building material, mixing it with a binding agent to print robust habitats. The speed and cost efficiency of three-dimensional printing could allow us to design and build co-living spaces, eco-villages, and communities centered around shared values and sustainable living. The curved, organic forms that are so easy for a printer to create could lead to a new architectural language, one that is more in harmony with the natural world. Beyond the creation of futuristic neighborhoods and Martian outposts, three-dimensional printing technology holds a more immediate and profound potential to provide safe, dignified shelter in times of desperate need. A convoy of trucks arrives, carrying mobile three-dimensional printers. Within days, the machines are at work, printing the sturdy, permanent cores of new homes directly onto cleared foundations. In places like rural Mexico, families who have lived in shacks made of scrap wood and metal are now moving into secure, comfortable printed homes. These are not just shelters, they are foundations for better lives. The spirit of innovation driving this movement is profoundly humanitarian. They see a world where safe housing is not a luxury, but a fundamental human right. We stand today at the threshold of a new age of creation. The simple, elegant process of three-dimensional printing a home layer by careful layer is more than just a technological marvel. It is a symbol of a broader shift in our thinking. The quiet hum of the three-dimensional printer is the sound of a new beginning. It is the sound of homes being created for those who have none, the sound of communities being rebuilt with astonishing speed, and the sound of a more sustainable relationship being forged between humanity and the planet we call home.